Gas leaks in your GC system, how to find and eliminate them. Featuring the Restek Electronic Leak Detector. Even a small leak in your GC or gas lines can result in the loss of sensitivity, sample, and valuable high-purity gas. A leak can also damage your column and instrumentation as well as contaminate samples. The Restek Electronic Leak Detector is an essential tool for troubleshooting and routine maintenance of your gas chromatograph. It should be used daily to ensure that your instrument and gas delivery systems are in top working condition. Full instructions are available at www.restek.com/leak-detector. But here is a quick overview of some best practices for leak checking and maintenance. Prior to leak checking a GC, we recommend that you increase system pressure while the GC is cool to accentuate any potential leaks and make them easier to detect. Then, after bringing the system up to operating temperature, be sure to recheck critical seals. You should leak check your gas delivery system and instrument, especially the critical seals, on a daily basis. The septum is a common source of leaks. If the septum is leaking, simply replace it. By checking the septum regularly, you will be able to learn how long your septum generally lasts, and then avoid unplanned downtime by anticipating when to change it before it starts to leak. Incorrectly tightening the septum nut or injection port weldment after changing the septum and liner can lead to leaks. To fix a leak here, try loosening and correctly retightening the nut or weldment. Frequently moving the injection port weldment can crack the welding around gas lines. A leak can indicate that cracks have developed and that the weldment should be replaced. Leaks around the bottom of the inlet, specifically the reducing nuts, column nuts, and detector nuts, are common, especially since temperature cycling can loosen nuts that are not properly tightened. In addition, ferrules, especially Vespel graphite blend ferrules, tend to shrink slightly after initial heating cycles, which may also lead to a leak. If you encounter a leak near the column nut, reducing nut, or other threaded connection, first attempt to fully tighten the nut. After the fitting has been tightened, recheck it to confirm that the leak has been eliminated. Column connectors are common sources for leaks, even if they are leak-free after initial installation. Check them regularly during use. Reinstallation may be necessary if you discover a leak. Detector nuts from atmospheric pressure detectors such as FIDs and TCDs can also leak if improperly tightened or if a column breaks during installation. We do not recommend the use of a leak detector to check MSD nuts because the vacuum draws in any leaking gases and prevents detection of a leak. Performing an air-water check using your mass spectrometer will indicate if there is a leak in your system. As moving parts and valves age and wear, they can become another common location for leaks. Replacement may be necessary. After installing new gas lines, always remember to pressurize the system and check for leaks. Check for leaks anytime you install new or replacement gas filters. If one of your gas filter compression fittings is leaking, check the fitting to make sure it's in good condition. Then, tighten it appropriately. Afterwards, continue to routinely check around seals and fittings. Leaks aren't always immediately near your GC. After changing gas cylinders, you should also check around the regulator. Be sure to check any manifolds as well.
Flowmeters are often seen as essential tools for GC labs. But since modern instruments feature advanced pressure controls, valves, and built-in flow measurement software, is it necessary to have a handheld electronic flow meter? In this Restek tip, we're going to discuss flow meters. What are some of the situations they can be used in, and why would you use one instead of your instrument, specifically focusing on gas chromatography? Let's begin with the why. One of the biggest reasons to have a standalone flow meter is for troubleshooting. Whether you're seeing issues with an analysis you've performed hundreds of times, or are developing a new method, it can be useful to have a separate, calibrated tool dedicated to measuring gas flow. Its flexibility lets you measure flow throughout the instrument, making it perfectly suited for part of your routine maintenance schedule. And its portability means you can take it on the road. Perfect for analyses performed in the field. So, what are some specific applications for an electronic flow meter? Measuring column flow. Starting with the column, a great use for a flow meter is measuring column flow. While this can be an excellent troubleshooting step for all columns, packed and micropacked columns stand to benefit the most due to pressure drop variations. Measuring fuel gases. Detectors like FIDs rely on specific gas ratios, in this case, air and hydrogen. These ratios have a limited range in which they can fluctuate in order to maintain proper function of the detector, and a flow meter can help you monitor and stay within the ratio. Calculating split ratios. By measuring the split and column flows, a flow meter can help you calculate the split ratio. This can be useful when you want to verify that your ratio is correct and that the traps, restrictions, and valves are functioning normally. Verify results. Handheld, calibrated electronic flow meters can also be used to verify results obtained from onboard instrument software. Whether you're performing troubleshooting or routine maintenance, being able to double-check your results is a great ability to have in your hand. These are just some of the many uses of a flow meter, but as you can see from their versatility and usefulness, these tools should have a place in every lab. If you have any questions or want to learn more, check out our resources below and visit us at restek.com. Thank you for joining us for this Restek tip.